Okay, in example number 3, is on circular shifting of time domain sequence. Example 4 is on circular shifting of frequency domain sequence. Okay, so by right, okay, you must remember the two given equation I give to you just now. Okay, so basically in example 5 and 6, how to solve circular convolution. Okay, again, why we have this word circular? Okay, for DFT you have to circulate the sequence. Okay, that's why we have the term circular. Okay, in DTFT we have convolution. Same goes to DFT. We still have some convolution. Okay, in chapter 5, this circular convolution is indicated by this one, by this symbol. Okay, this is in chapter 5 for DFT. When it comes to DTFT, we just have this symbol, okay, to show that this is circular. This is convolution. Okay, when you see this symbol, okay, definitely you know that it's referring to DTFT. Okay, when you see this symbol, definitely you know that it is DFT. Okay, why we have this one? Okay, this circle represent circular. Okay, so basically if let's say you see circle 4, means you have to do length for circular convolution. If you see circle 8, means you have to solve length 8 circular convolution. Alright, so in circular convolution, you have to remember this equation. YC. Okay, Y indicate output, C indicate circular convolution. Okay, so we have summation, okay, M from 0 to N minus 1, and then we have G M. Okay, so basically this equation you must remember. Okay, now we move to example 5. Okay, please read the question. Okay, the question asks you to determine the 4-point circular convolution of two length 4 sequence Gn and Hn given by. Okay, so first keywords we have length 4. So again, length 4 describe your capital N is equal to 4. Okay, next you have to determine the circular convolution of given sequence. Okay, determine circular convolution of Gn So for you to answer this question, you have to remember the general equation of circular convolution. In circular convolution equation, okay, you have YCN, the output. This equation is circular convolution of Gn for Hn. Why 4? Because our capital N is 4. Okay, and this is equal to m equal to 0, n minus 1, Gm H n minus m. Okay, so I repeat, in this case, m n minus 1, Gm H n minus m. Okay, so just now, okay, please correct your notes. It is not capital N, it is small n, n minus m. Okay. Okay, now we have this equation. So what you have to do next is, from this capital N, you know that the range is from 0 to 3. So basically, YCN you have to find for YC0, YC1, YC2, and YC3 equal to what? YC0. Okay, so G0 circular convolution with H0. So we will have M from 0 to N minus 1. So we have, so first Gm is 0. So okay, so first is 0. So we have 0. So your Gn, okay, your capital N is 0. So we have H0 minus 0 is 0. Okay, next G1. So we will have G1. Okay, so H, right? Okay, your N is 0 minus 1. So you have H minus 1. So H minus 1, this one is actually H4 minus 1. So this will become G1 H3. Same goes to G2 H0 minus 2, 4. So this one is equal to H4 minus 0, and this will become G2 H2, and then we have plus G3 H0 minus 3. So this will become H4 minus 3, and this one will become G3 H1. So basically, you have to find for G0 H0, not okay, 0 minus 0 is 0, okay, plus G1 H3 plus G2 H2 plus G3 H1. Okay, alright, go back to the question. G0 is 1. H0 is 2. So 1 times 2. So you have to follow this one. Okay, follow the sequence. Okay, so you have G0 is 1. H0 is 2. Plus G1 is 2. H3 is 1. And then plus 0 times 1 plus 1 times 2. So you will get 6. This is for YC0. So YC1. So YC1, same thing. It is all about G1 circular convolution with H1. So it is from m equal to 0 equal to 3 until 3. Okay, Gm H n minus m. Your n is 1. Okay, your n is now 1. So first we start with G0. M is equal to 0. So this one is H1. So you don't have to do anything. Okay, next we start with G1. And then H1 minus 1 is 0. So this one is H0. Okay, and then G2 H1 minus 2. So now it is H minus 1. So you cannot find this one. It is actually, you have to use H for minus 1. So it is H3. And then we have G3 H1 minus 3. So H1 minus 3 is H minus 2. So H minus 2, H4 minus 2. So we have H2. So this one is equal to G0 H1 plus G1 H0 plus G2 H3 plus G3 H2. And then you refer to the sequence. You know that you have G0 is 1 times 2 plus 2 times 2 plus 0 times 1 plus 1 times 1. So you will get 7. Okay, YC2, this is n. Okay, so we have G2 circular convolution with H2. And then we have m from 0 to 3, n minus 1. This is n minus 1. Okay, Gm H n minus, sorry, not capital N. It is 2 minus m. Okay, so we start with G0. We substitute H2 minus 0 is 2. No problem. Okay, next G1. Let's do H2 minus 1 is 1. Next G2. So when m equal to 2, this become H0 plus we have G3. Now this one will become H minus 1. So H minus 1, you have to minus 4 minus 1. This is n. Okay, so 4 minus 1 is H3. So here we will have G0, H2, okay, so G1 is 1 times 1 plus, together you sum, you get 6. This is for YC2. Okay, same goes to YC3. So in YC3, same thing. Okay, you have G3, circular convolution, and then H3. So you will have m from 0 to 3, Gm, H3 minus m, 4. So from here you have, okay, you substitute one by one. G0, so first H3 plus G1 H. Okay, you substitute m with 1, so you get H2. You need to multiply and then you have to sum. Okay, so after you multiply, after you sum, you will get 5. YCN for the given Gn and Hn is YCN of Gn circular convolution of Hn is equal to YC0, the value is 6. YC1, the value is 7. YC2, the value is 6. YC3, the value is 5. So the range is from 0 to 3. Done. Okay, for example number 6. Okay, please read through the question. Okay, so from the question you have to finite line sequence Gn equal to, so if you look at these two sequence, you have two different sequence. Okay, two different range. Okay, one is from 0 to 2, another one is from 0 to 3. So what happened in the question is already state that you need to extend Gn to a line 4 sequence. Okay, so if you look at this Gn is line 3 sequence, means the capital N is equal to 3. So what you have to do is you need to extend your n equal to 3 become n equal to 4. So go back to the question. You need to extend the Gn become Gen by 0 padding. Means your new Gn, which is Gen, is equal to 2 minus 1, 3. When n equal to 3, the value is, so the range is from 0 to 3. Why we just have to add 0 at n equal to 3? Because of this one is coming from 0 padding technique. Means the additional range, the additional n, you need to just add zeros. means at n equal to 3, the value is 0. Okay, alright, so next, the question asks you to find YCN equal to GEN circular convolution of 4 HN. For this example, to answer the final answer for YCN, you need to follow the same step as example 5. Alright, so basically this example is actually the extended of chapter 2 technique, which is zero padding. So lastly, I hope you, from this example, you really understand the fundamental aspect of circular convolution for DFT, and at the same time, I hope you also remember on the technique of the zero padding, which is coming from chapter 2. Alright, so basically that's the end for the example of circular shifting and also circular convolution. So good luck and all the best. Thank you.